Hello everyone, my name is James, and today I will talk about climate and weather factors affecting winter sheltering by shoreline Copper Rockfish Sebastes caurinus in Howe Sound, British Columbia. And first, what is copper rockfish? It is a kind of sea fish, live in subtropical and live in the rock bottom and bay or sound where seaweed grows. And its distribution is from the Gulf of Alaska to central Baja California, Mexico. And where is Howe Sound? And it is in Canada, and we amplify the picture. The map is roughly northwest side of Vancouver. And in earlier research, we found that during late autumn and winter, copper rockfish increase their use of interstices of boulder piles where they become relatively inactive, and this is so-called winter sheltering. So, we want to know the link between local weather patterns, large-scale climate indices, and rockfish sheltering behavior. The local weather patterns, which are windstorms and river floods. The large-scale climate indices are El Nino and La Ninas. Let's present the two phenomena simply. El Nino will lead to sea surface temperature become warmer, and La Nina will lead to sea surface temperature become colder. Methods. In this research, we use scuba conduct 179 surveys from 2006 to 2019 with 2 divers inspecting boulder interstices and holes with dive lights. And to ensure the entry and exit timing was accurately captured, surveys were conducted bi-weekly, means twice a week, from late October through late November, and early April through early May. We detect wind speed data to determine windstorm events, and peak flood data is using max discharge to determine peak flood date. We also detect the oceanic Nile index, and shortly we call it ONI. And ONI has a formula. It is in the Central Pacific Ocean, the average of sea surface temperature minus the average of climate temperature. And when ONI value is larger than positive 0.5 Celsius degrees for 5 continuous months, and it is El Nino. When ONI value smaller than minus 0.5 Celsius degrees for 5 continuous months, and it is La Ninas. Results. We found that in 10 out of 13 years, winter sheltering in boulders occur closely after strong windstorms during autumn. And there are early sheltering. This means before November 1st, occurred during 4 strong La Nina winters in 2007 and 2010, 2011, and 2017, result in hiding duration of 197 to 241 days during winters with anomalies from minus 1.6 to minus 0.86 Celsius degrees. And there are also late exit sheltering, means after mid-May, occurred during the La Nina spring of 2008 and 2011. Exit was particularly late in 2011 because in this year there was a strong La Ninas, and the river flow timing in this year is July 4th, which was the latest in the 13 years of the study. And we can see the 2 week La Nina winter have a hiding periods of 152 and 177 days. It's similar to the 2 normal and El Nino years, which had a range of 124 to 174 days. And let's look at this chart. The black column is the amount of fish in, and the gray column is the amount of fish out. And fish were sheltering in boulders from November to April. And we can see there are very few fish go out during December to March. And the chart, the total population size is about 200. But the number of fish during central winter months of December to February, it do not significant increase in counts, and compared to early winter and late winter. And in this chart, the blue point is La Nina event, orange is El Nino event, and the cross is in normal year. The 2 low anomalies are for strong La Ninas. The greatest positive anomalies is for El Ninos. We can see the sheltering duration during El Ninos did not differ much from the 2 normal winters and the 2 weak La Ninas. But however, the lines is the duration of sheltering decreased significantly with increasing ONI anomalies. Discussion. So we found entry into sheltering is primarily driven by Arctic outflow windstorm with strong La Nina events linked to prolonged sheltering of over 7 months. The greatest reduction in overall number size was during January, likely related to continuing intensity of Arctic outflow wind during November to January. As the winter progressed, fish were observed to move deeper crevices where for the most part we could not detect them. So in these 3 months, we cannot record the significant increase in counts. And mortality due to predator or fishing during the winter sheltering period may be minimal. The advantages of sheltering could contribute to longer lifespan. Greater longevity would increase the odds means rate of reproducing in the relatively infrequent years, favorable to larval survival. And sheltering duration appeared to only increase with ONI anomalies of positive or minus 0.8 Celsius degrees or more, and more so for La Nina's events than for El Nino. Currently, and ONI anomalies of 0.5 Celsius degrees are utilized for defining ONI events, but the copper rockfish only seem to attend to average anomalies like minus 0.86 Celsius degrees for La Nina or 0.82 Celsius degrees for El Ninos, or greater with respect to significant behavioral responses, and it may be that a higher threshold for defining ONI events may better represent the biological patterns observed here. Thanks for listening.
What is the Fraser River threshold?
Oh, and it is the date of.
What was her question?
She wants to know what is Fraser River threshold, and this is the date that they record for river flood. Yeah, river flood date.
I want to know your
What is this
yeah,
and this?
Copper Rockfish only sent to attend to a village.
Did you repeat what was his
Oh
question?
no.
What was his question?
He wants to know why I know the minus 0.86 for La Ninas and 0.82 for El Ninos, right?
Yes.
And this two value is our example and example for this here
Okay.
for La
I see
Ninas
that.
and El Ninos.
Sorry, could you please repeat the purpose again? Because I not remember that.
Because the copper rockfish have a winter sheltering behavior, so we want to know the link between the local weather patterns, which are windstorm and river floods, and large-scale climate indices, which are El Ninos and La Ninas, and rockfish sheltering behavior. We want to know the link between the three.
Addition to local weather and climate, have any other help to us?
Repeat the question.
She wants to know, is there any other local weather patterns or climate indices link with rockfish sheltering behavior? In the paper, they didn't say any other factors. We measured discussed the factors are windstorm and river floods and El Ninos and La Ninas.
You said that the fish only distributed in the west coast of North America. Is that the reason why you choose this species? You choose to study this species?
Oh, and he say, is the fish distribute only in North America?
Yeah, in the west coast of North America.
In the West and North America, and why I choose the species. Oh, the distribution of copper rockfish is what I found is in Wikipedia, and in the research they didn't mention about the distribution of copper rockfish and why we choose the fish. It is choose from the research. I just do the research and show you what is the paper saying.
How do you know there's in and out?
Repeat his question.
He want to know how I know the in and out. I think the divers is counting for the fish.
Does this mean these fish go in this area or they go out?
And yeah, and but the I think it's
Is there will have any difference from the rockfish which lives in Canada and between the one which lives in Gulf of Mexico?
and he wants to know, is there a difference between Alaska, the rockfish in Alaska and in California, Mexico? I don't know. The paper didn't say that.
All right, since we are at this slide, I can correct one of the pronunciation. So because this is in Mexico, so this reads Baja, not, all right? All right, and there's another pronunciation because it's Spanish, and here this reads interstices. And his presentation was quite fluent, and so the slides were, so you see there were a lot of images, and he also colored the keywords. But I think there's some place where it can be improved. So the method part is good. And so first of all, I have mentioned many times, usually I do not like to see a copied table from the paper, because that could mean that you have not really digest the data. So usually I prefer that you can remake the table yourself and you can try to simplify it. You show the data that is only important for your talk. You can somehow simplify the table, and also you can enlarge the font. For example, the font is actually quite small here. And you can also color the number. So that's the reason why I always like to see you remake the table yourself. And when you were presenting the table, you were not really introducing all the parameters here. So at the end, so I think that's one of why one of the audience asked, what is Fraser River freshet? We have no idea. And there's a date and there's a numbers of what they are. So that's there's confusion. So when you present the table, if you cannot convert it to a figure, you really have to present the table. Please remember to introduce things here, because you cannot expect that everybody knows those automatically. And then, and I would always prefer that you talk about the data first before you talk about, I think this should be a little bit like what you want to conclude those blue boxes, right? So these are concluding the boxes here. So present the data first and then the conclusion, concluding remark. And so we see several slides here, and these can be improved next time. And then when you were presenting the figure, it's a little bit the same, like I always prefer that you talk about axis, and I think when you were presenting your figures, you always forgot to present what is the y-axis. So please remember, here you remember to present what's in and out, but I don't remember, did you say what is in? I think one of Jason asked, do you mean in this area? I don't know if that's your question, but I think the in means into the interstices, right? Beneath the rock. That's the definition. So I have to say clearly. Yeah. And then, wow, time's up. Yeah. Right. And here you also forgot to introduce the axis. And then go to the discussion. Here is, I saw that you try to repeat the data here again. That's one way of doing it. But because in this way, you sort of separate the data and discussion. So it's better that you highlight the data that support the argument here again. For example, here you talk about windstorms. How do we know there's windstorm in this table? I don't know. So you have to make sure each item, each keywords here is supported by the data that you show again here. And the same thing is here. I think because Peter asked this question, these numbers, and you show the table again, but I think what you should actually show again is this figure. Apparently, below minus 0.8 and above, or within minus 0.8 and plus 0.8, it seems like there's no difference. I think that's what you want to say. So I think this is the right figure for you to support this argument, not the table, because we cannot see any pattern from the table. All right. And lastly, I suggest that you add a conclusion to wrap up your data your findings next time. It's always good to have that. Okay, let's thank James.